Hey everyone, I'm building an entire first-person shooter game from scratch in the Godot engine and documenting the progress with these tutorials. In this video, we're creating a procedural bob animation for our weapon when the player moves. The basic FPS controller project from episode 1 is available for free on GitHub, and if you would like to download all of the source files, you can get access by joining my Patreon. Let's dive in. So if you've been following the tutorial series so far, you know that we have a look sway animation that we've procedurally set up, and we've also set up a randomized idle animation that you can see right there. The goal for this video is to add a bobbing animation for when the player moves, and to do that we need to adjust some of the code that we've already done. Now if we go into our weapon script where we're running our swaying scripts, we currently are running that sway weapon animation every single frame, and we're running it from this script. So the first goal we have is to separate out this swaying animation and our idle animation so we can control it from our movement states. To do that, I'm in the initiate weapon script where we have our sway weapon animation function, and you can see that this whole area right here is our sway weapon code. Now a lot of this code is actually dedicated to that idle animation, and we want to separate that out, right? So what we're going to do is add another parameter to our sway weapon function, is idle, which will be a Boolean. So whenever we run this function, we can determine whether or not we want that idle random animation to run. The next step is to extract that idle logic from this function, and we can do that by creating an if function. So if is idle, which again is going to check our parameter, we want to run anything that is related to our idle random animation. In this case, our get sway noise and anything related to our time from our delta and our random sway is all related to that idle. So we want to put that underneath that if statement. Our mouse movement is actually going to happen regardless, so we can move that up to the top so that it runs regardless of what our if statement is saying. And then the next few lines of code are where we have the distinction. And there's a lot going on. It's mainly because my variable names are super long, but everything in this line, for example, is going to run regardless, except for right here where we're adding our random sway X to the X position of our weapon. That's where that idle animation is coming in. Down here in our rotation, we're doing the same thing, but we've added an idle sway rotation strength variable. So this line right here can be cut, and then we've extracted our idle animation. So what we can do is maybe a little bit chunky, but let's move all of that into our is idle if statement. We're going to keep that random idle movement within our position and rotation, and then we create our else statement. So if we're not idle, we don't want that to run. We'll copy this over, paste it down here. Then we can take out our random sway X, random sway Y, and take out that same thing from our rotation setup, making sure we don't get rid of our parenthesis down there. Now, whenever we run our sway weapon function and we set our is idle to true, our code's going to run as it's been running and include that random idle animation. If we set it to false, then we're going to leave out that idle animation, which is exactly what we want. Now that we've separated that out, we can also delete this so we're not running it every frame from this script because we want to run it from our movement states. Now, in order to run anything within our weapon script like we do with our player script, we need to be able to access this weapon script from our states. So let's open up our idle player state, and you'll notice that we're extending our player movement state, which is a version of our state script that is adding some references to things that we can grab from all of our states. So let's open that up. We can do that by hitting Control and clicking on it within the script. And you'll see that we have a reference to our player, and we have a reference to our animation. So whenever we ready this script, we wait till everything loads, and then we set the player variable as the owner, which is, in this case, our FPS controller, and we use that same information to then grab our animation player. And just like we did for our animation, we're going to do the same thing to get our weapon script. So let's go back to our FPS controller script and see how we did that. All we did was create an export variable and then assigned it to our animation player, because that animation player is in our FPS controller scene. So let's do that same thing for our weapon script. We'll add an export variable. We'll call this weapon controller, and then we need a type, right? Normally you could do a node 3D and then you could select any node 3D relevant node within your scene. But I always like to have autofill available so the scripts know what script I'm using, and it makes a little bit more sense and is a little bit easier. It's also faster, it's more optimized. So let's do that. Let's go into our initiate weapon script, which I guess we should probably rename at some point because it's doing a lot more than just initiating our weapon. And we're going to add a class name. So when we do that, we're creating a specific type for the script. And if we use that type, then the engine's going to know, I know exactly what script that's going to, and it's going to fill out all of our variables, all of our functions, and it's going to make it a lot easier to work with. So let's do that by going up here to our extends line and adding class name. And then let's call this weapon controller, okay? Because that's really what it's becoming. It's becoming the controller script for our weapon system. Now that we've done that, we save our script, and let's go back to our FPS controller, and instead of node 3D, let's look for our weapon controller reference, and there it is. So now that we've set that, it knows within our export variable, and if we go into our FPS controller scene, we can do that by clicking right there. Go into our main node where our script is, and you'll see our export variable weapon controller has shown up, and we can assign. And notice that weapon is the only node that is showing up. That's because we've set the type to weapon controller. We select that, and now we have a reference to our weapon controller node, and therefore the script. Now that that's ready, let's go back to our player movement state script, where we can create that reference for all of our states. So we'll add another variable. We'll call this weapon, and we'll call the type, again, so we know what we're working with when we're doing our script, to weapon controller. And just like we did for our animation reference, when we are readying our script, we'll set weapon to equal, we'll grab a reference to our player controller, and then our weapon controller. Now you might think because we've put it in the scripts, then yay, we can get a reference to our weapons within the script. But again, remember, if we go back to our idle player state, we're extending from our player movement state. So what does that mean? It means any script that's extending from our player movement state is going to already include all of this information. Essentially, we don't need to create a new reference every time we create a new movement state. So let's add back our sway, because if we run our scene right now, we've lost our idle movement, we've lost our sway movement. That's because we're not running the function anymore. So let's add that back in, except now we can do it with our movement states. So in our idle player state, we're going to run our sway weapon function that we just adjusted in our update, or our process version in our states right here. So let's add a reference to our weapon, and you'll notice that we have all of our functions and variables showing up in our autofill, and that's because, again, we set our class. Now we're looking for our sway weapon function. So we add that in. It's going to ask for our delta, which is already a part of our update function. And then it's also going to be asking for our Boolean. Remember, we have that show back up here. So it's also asking for our is idle Boolean. So in the idle state, we want that to be true. We finish our function off and we save. Now let's check to make sure that everything is running like it's supposed to. All right, we have our idle random animation running. And if we look around, we have our look animation running, although it's maybe a little bit too strong, but that's fine. Now let's add this back to any state that we want to have our swaying animations run. So in my opinion, I think idle obviously makes a lot of sense. Let's also do it within our walking state. So we'll do the same thing. We'll go down here at our weapon reference. In fact, you can just copy that code. And instead of true, because we're not going to be idle, we set that to false. And by setting it to false, we will not run any random idle animation. That same thing can be done for our sprinting. So we paste that back in there. And then also, I would say the crouching. We can do that same thing. And we can save all of those scripts and we should be ready to go. Now, before we test, you might be thinking, well, okay, why are we not doing it in the sliding, the jumping, and the falling? Well, we can. All we need to do is add that line into that script. If we wanted to add it to falling per se, you just add that line, you're good to go. In this case, I think those might call for a little bit of a different treatment of that swaying motion. But for now, let's test our idle, our walking, our sprinting, and our crouching. We can run our debug panel to check which state we're in. Our idle is working fine. Now, when we walk, we should lose that random motion, which we do, and we should keep our looking, which we do. Let's test our sprinting. That's working fine. And then finally our crouch. And it looks like we're good to go. Okay, so we've separated everything out. We've got it running from the states. Why did I even do that? Well, because we're going to add a bobbing animation, I want a little bit more control over when that runs. And if we do it within our states, it also means we can set up individual variables within those states to control the strength, how much motion there is, and we're going to have a lot more control over our procedural animation. So let's get started on that code. To get this motion, I'm going to use something very similar to what I did with the swaying animation, and that's going to be to use a sine wave. Now let's think about what our gun is actually going to be doing when we have this bobbing animation. To me, at its most simplest, you're going to have this left and right movement back and forth, and then you're going to have a movement up and down, although probably not down because that's going to look a little weird. It's going to be almost like this bouncing effect. And we'll use some math to get there. But first, let's illustrate what that sine wave is going to look like. So this is Desmos. This is a really cool graphing tool that you can get online. And what I've put in is a simple sine function. It's just y equals the sine of x. So as x progresses, you're going to see y go up to 1 and then back down to -1. I'm going to flip this so you can see a little bit more of what I'm talking about with that left and right motion. So let's do x equals sine of y. And imagine now this is our left and right movement of our gun. So as time progresses, which is what y will end up being, we want our gun to go right, left, right, and so on. So to start this, we're going to go back to our weapon controller, initiate weapon script, and we're going to add a new function. And that function is going to be weapon bob. We're going to need a delta value within our parameters because we're going to run it every single frame, and we'll set up void because we're not going to use this to return any value. So for the first step, let's just see if we can get our weapon to move left and right within our editor. Okay, so to do that, we have our weapon bob, we have our delta parameter, and then we're going to need time because we're going to use time within our sine function. So we do time plus equals delta, and we can just use that as a base. And then let's set the position x of our weapon to equal the sine of time, all right? And then we're going to see what that does. And in order to see this in the editor, let's go ahead and add back our process function. And within this function, we will run weapon bob and add delta. Okay, so we've got our position of our weapon going left and right. In fact, let me undo the camera there and you can see it a little bit easier. So there's our weapon. You can see that sine function is going left to right. Obviously it's way too much movement, but we can adjust that. So let's do that. Go back to our script and we're going to add a parameter within our weapon bob function. In fact, we can add 2 parameters so we can adjust the speed of that movement and also the amount of that movement. So let's add our speed first. We're going to call this bob speed. It'll be a float. And we'll also add a horizontal h, bob amount, and that will also be a float. Now notice that our function is freaking out because we don't have enough parameters. Now to see how we're going to use these variables, let's actually go back to our graph. So this is the function that we currently have right now. We just have a right to left movement and it's going only so far. So we want to be able to increase the frequency, how many waves we get, and also adjust the amplitude, which is the distance to the left and to the right. To do the frequency, what you need to do is go into your sine function right there, and we're going to multiply that y value. So if we multiply it by 10, we've increased the frequency by 10. Or you can multiply it by a fraction, and then we've decreased it by 10. That will be where we put our bob speed. Now, if we want to adjust the amplitude, what we'll do is multiply everything by a value. Now you see that we've multiplied everything by 10, and we've increased that amplitude by quite a bit. Or we can multiply by something, a fraction of 1, and it's going to decrease that amplitude. So let's go back to our script. So again, our position x equals sine, and then time is our y in this case. We multiply that time by our bob speed, and then we multiply everything by our horizontal bob amount. Now when we put those into our parameter, let's say, let's increase the speed by 5, and then the horizontal bob amount, it was moving way too much. Let's do 0.2. We'll save that, and let's go back to our script. That'll be a little bit easier to see within our camera. All right, so it's still way too much bobbing movement, but the speed is a little bit better. So we can reduce that even more. Let's do this to 0.5. Check out our movement, and it's a little bit better. So we have our left and right movement. Let's get our vertical movement. Now you might think, okay, we've done our X position. Let's just use the same code and adjust our Y position. Well, let's put that in there and we'll see what happens. So we are now adjusting our Y position by the same thing, our sine times bob speed times horizontal bob amount. And obviously we're going to need a vertical bob amount. Let's save that and let's see what it's doing. All right, now we've got this kind of diagonal movement, okay? And if you think about it in terms of a graph, this makes sense. We're shifting between the left and right, back and forth, and we're also shifting between the up, down of our vertical. But it's happening at the same rate, which means we're just going to be going in a diagonal line. What we need to do is actually use cosine, and I'm going to show you what I mean. All right, so I've set up a sine and a cosine function, and it's actually a little bit harder to see this way, so I'm going to swap these with the y and x real quick, and it's going to make this a little bit easier to see. So we have our left and right movement, and now we have our vertical movement graph. And this doesn't look like much. In fact, if we go and put this in the script, it's not going to do what we want. What we want the vertical to do is almost bounce, right? We want it to bounce, because if you're having that up and down movement, it's not like this. It's more of a right? And we have that here. We need to add one more thing to our function. And that is we need to take the absolute value of our function. And there's our bounce. Now, what does this exactly mean? So this is our left, right, left, right. So when our gun is on the left or the right side, we want the vertical to be at its lowest point. And when it's in the middle of those two, we want it at the highest, right? We want this sort of arc movement. And you'll notice that when we're at our left, our Y position's at 0. When we're at our right, it's at 0. And when we're in between, it's at its highest point. So that's why we need cosine and the absolute value. Although an offset sign would also work. Let's go back to our script and let's make this adjustment and see what we get. So instead of this sine, what we're going to do, we're going to get rid of that, and we're going to take the absolute value of cosine time, and then we're going to need a vertical bob amount, so we'll add that back in. And then we also need to add in our bob speed, or everything's going to be wrong too. So here's the line for the Y position. We're going to take the absolute value of our cosine of time times our bob speed, and then multiply that by our vertical bob amount, which we've set to the same as our horizontal, but we can adjust that later. Now let's take a look at our motion. And there we go. Now we have that bouncing animation that we can adjust. Maybe we can make our vertical a little bit less, make the horizontal a little bit less, And there you've got a procedural bob animation. Not too bad for a couple lines of code, right? Now we need to make this actually functional within the scripts that we're using and have it work in game. So we're not going to be running this weapon bob function within our weapons function. We're going to do the same thing that we're doing with our sway weapon function and run it from our state scripts. So let's delete that. We don't need it. The function itself is fine. We're just going to go to our state. So let's go to our walking state. And let's do the same thing that we did with our sway weapon. We'll get a reference to our weapon script and then run our weapon bob. And we'll do a delta, and I think we said 5 on that, horizontal amount 0.2, and then a vertical amount of 0.1. And if you're thinking, hey, we can just put those in variables, you're right, and we will. And if we walk, we should get our bobbing animation. Let's see what happens. All right, we have our bobbing animation. It just is not very good. We can fix this and do it pretty easily. So let's go back to our initiate weapon script, and we're going to add a variable. We're going to call this variable weapon bob amount. And this is going to be a vector2, and we'll default it to 0. Now what we're going to do is, instead of setting the position of our x and y, which is again setting the position of our node, we're going to set the x and y of this variable. So we set weapon bob amount x to equal and weapon bob amount y to equal. Well, we already have lerps to handle any movement of the weapon, so let's just put them in there. So we have our 2 position lerps right here, right here. This is for when we want our idle animation, which we're not going to be bobbing if we're idle. And this is when we're doing anything else, which is moving, running, walking, whatever. This is where we want it. So we're going to add it right in here, and it's going to be our weapon bob amount x. This is going to take that x value that we've set, add it into our position lerp, which is already taking into account the position of the weapon and everything that we need. Let's do the same thing for our y, weapon bob amount y, and let's test. All right, now it's subtle, but it's there. I just need to increase the values a little bit. You can see that slight bob movement already. So you can see it just a little bit clearer. We'll go back to our walking. We'll make the horizontal amount, let's make it 2. Make it real obvious, 0.5. Let's check it again. There you go. So now we're adding that bob movement in relation to all the other movement information that we've already set. So we're almost there. We just need to do a couple things, and that is to adjust these to become export variables within each of our states, and then take this function and run it with any state we need it in. And all of that is actually very easy. So let's take our walking player state first, and what we're going to do is add 3 export variables. The first one's going to be the weapon bob speed. The next one will be our weapon bob horizontal movement. And the final one will be our weapon bob vertical movement. And we should set each of these to a float. Types are good. And for the speed, let's set this to 6. Or the horizontal, let's set it to 2. And set this to 1 as a default. Now this means that you can adjust and individually set all of these settings within each of the states, which is what we want. And then we can go down here and replace our values, our parameters, with these variables. All right, now let's test that out. There we go. Now these may not be the exact values you want or the best looking values, but again, it's very easy to adjust. So let's add all of this to any other states that we need. Sprinting and crouching states. We're going to add this same logic. So we can simply copy, go back to our sprints, paste that in below our sway weapon, and then go back and then copy all of these export variables and paste those in. Now for the sprinting, you're going to have it be probably a little bit faster, right? We can make that 8, make a little bit more movement horizontally, maybe a little bit more movement vertically. And then for our crouching, let's go ahead and paste that function as well. And paste our export variables. Speed for this is going to be slower, make it 2, a little bit less movement. And let's go with that. Now we should be able to test each of these movement states, and we should see a different bobbing pattern for each one. All right, we are in idle, no bobbing. We're in our walking player state. We are bobbing. All right, now let's crouch. It's a very slow bob. Go back to walking. We run. It's even faster. And there you go. All right, guys, if this tutorial was helpful, consider a like and subscribe to the channel, as we're going to be covering a lot more. Thanks to all of my patrons who keep this series going. You too can get access to the project source files by joining my Patreon. You can download everything there, and you'll also get early access to my videos and sneak peeks at future tutorials. Thanks for watching, and as always, keep creating.